2b. The equation of the curve is given by 4x squared plus y equals to 4x squared plus 1. Find in terms of p the equation of the tangent to the curve at the point p, 4p squared plus 1. So what does this mean? Well, let's take a look at what we're dealing with first. We actually know what type of curve this is. This is just going to be a parabola, right? So if I just do a quick sketch of it over here, this will be a very quick, very rough sketch. X-axis, y-axis. It's going to cut at 0, 1 and looks something like that. This is not the neatest one, I'm sorry. It's not that easy to draw on the computer, but this is roughly what we're looking at. And so I have a point on this curve, A, P, 4p squared plus 1. And you'll notice that this is just the equation of the curve. Y equals to 4x squared plus 1. So if x equals to p, y equals to 4p squared plus 1. Nothing to get too nervous about. So what do we need to do? We just need to find the equation of the tangent to the curve at this point. So you know that the tangent, the equation of the tangent, so the tangent is a straight line. And so to find out the equation of a straight line, I need two things. The first thing I need is I need a point on the line, which I have already, right? A, P, 4p squared plus 1. It's a tangent, so it must pass through this point at some point somewhere. So it looks somewhat like, sorry, this is not the neatest drawing, but it would look something like that, right? And so A must lie on this line. So I've got the point on the line, and the second thing I need is the gradient of the line. So how do I find the gradient of the tangent? Well, I know the gradient of the tangent is equal to the gradient of the curve at that point. So all I'm going to do is find the gradient of the curve at A. So first thing I need to do, find what is dy by dx. dy by dx is just going to be differentiate this. I get 8x, differentiate 1, nothing, right? And so in particular, if I want to know the derivative at the point A, well, that's the derivative when x is equal to p, and that's just going to be 8p. So what's the equation of my line? Well, the formula is y minus y1 equals to m x minus x1, where x1, y1 is our point here. So I get y minus 4p squared plus 1 is equal to 8p x minus p. So rearranging that, I would get y equals to 8px minus 8p squared plus 4p squared minus 1, plus 1, sorry. Y equals to 8px minus 4p squared plus 1. And this is the equation of the tangent line to the curve at the point A, P, 4p squared plus 1. For the second part here, we're told that the normal of the curve at the point A meets the x-axis at C, and F is the foot of the perpendicular from A to the x-axis. Find length of CF in terms of P. Okay, so this is a bit complicated to think of. Again, I go back and look at my sketch. So if this is the sketch of what's going on, oh gosh, that's terrible, Mark. Let's try that again. Well, that's marginally better. Still pretty horrid. So we've got this point here, which is 0, 1. And we know a curve looks something like this, with a bit less lumpy, a bit less potato-like. And we know that this is the point A, P, 4p squared plus 1. This is the line y equals to 4x squared plus 1. And we know we've got a normal to this that looks something like that, passing through that point with gradient 8p. And then we've got, this is the tangent, sorry, and then we've got the normal to the curve at point A meets the x-axis at C. So the normal we know is perpendicular to the tangent, so that this in here is a right angle, And if I extend my x-axis along a little bit, sorry, didn't realize I'd need more. This point here, where it meets, is the point C. F is the foot of the perpendicular from the point A to the x-axis. So this point here is F. Find the length of CF in terms of P. Well, okay, I can do this, but if I want to do this, what do I need to know? I need to know the coordinates of F and the coordinates of C. Now, the coordinate of F is actually quite easy. If you look at it, this is just having the same x value as A, right? But it's on the on the x-axis, so the y value is 0. So I can say straight away, just from looking at this, and it's quite okay to see that the x value will be P, and the y value will be 0. So I know F already. What about C? Well, C is the x-intercept of the normal line. So to find C, I'm going to need to find the equation of the normal first. Okay, well that's not too bad, because the normal is just a straight line. So because it's a straight line, I need two things. Firstly, I need a point on the line. So what's a point on my normal line? Well, it passes through A. So I know that this point, P 4P squared plus 1, must lie on my normal. What's the second thing I need? I need the gradient. But again, this is still not too bad. Why? Because I know that the gradient of the normal is minus 1 over the gradient of the tangent. And I know what the gradient of the tangent is. That's 8p. So I've found out what the gradient of the normal is. So what's the equation of the normal? Well, y minus y1 equals to m x minus x1. So y minus 4p squared plus 1 is equal to minus 1 over 8p x minus p. So y is equal to minus 1 over 8p x plus 1 over 8 plus 4p squared plus 1. Okay, so now I want to know the coordinate of the point C. So what do I know about the point C? Well, all I know is that the y coordinate is going to be 0, right? It's on the x-axis. So when y equals to 0, what does x equal to? Well, we get this equation. This will be 9 over 8 plus 4p squared. So minus 1 over 8p times x is equal to minus 9 over 8 minus 4p squared. So x will be 9p. So multiply everything through by negative 8p. So get 9p plus 32p cubed. So that's the x coordinate. I can tell you, therefore, the point C is 9p plus 32p cubed, 0. So what does that mean about this distance? Well, this distance is just going to be the distance between C and F is just going to be because they're on the same line, I just have to find the difference in the x coordinates. So all it's going to be is 9p plus 32p cubed, which is the x coordinate of C, minus the x coordinate of F, which is p. And so that's just going to be 32p cubed minus 8 plus 8p. The last part asks us to find the area of this region B. So what can we say about this region B? Well, again, it's a bit hard if we just read it. So what I'm going to do is I'm going to draw it in first. X. So remember, this had the minima point there. This was the equation. This was our curve, and it had the equation y equals to 4x squared plus 1. We had some point here, which was a, p 4p squared plus 1. And if you recall, F is the foot of the perpendicular. So this is the point F, and that had location P, because it's the same x coordinate, is on the same x line as A, and because it's on the x-axis, it has a y coordinate of 0. So where is the area B? The area B is bounded by the curve, the x-axis, the y-axis, and this line AF. So that means that our curve B is, our region area B is this area in here. This is B. Okay, so how do I find that? Well, this area is just going to be the area under the curve between 0 and P, right? And the area under the curve is just the definite integral. So area of B is just going to be the integral from here, which is 0, to F, which is x equals to P, of this curve, 4x squared plus 1, with respect to x. So actually, we know how to do this. This isn't too bad. This is 4x squared, so you increase the power by 1, divide by the new power. You get x cubed, 4 over 3, and 1 will just become x. Lower bound is 0, upper bound is p. So now we just substitute in upper bound minus lower bound, so you get 4 over 3 p cubed plus p minus 4 over 3 0 cubed plus 0. So that whole thing's just going to be 0. You get 4 over 3 p cubed plus p. And so that is the area of B. One important thing to notice for this question is that although it's all in terms of this funny point A is equal to P, 4p squared plus 1, there's nothing here that you couldn't do, right? It's all simple skills. It's all skills that you are well aware of how to do. So if you find yourself struggling with this question, struggling with this idea of this point here, I want you to try something. Instead of using A as P 4p squared plus 1, maybe this is too difficult, but why don't you see what you do if I give you the point A prime, let's call it, and I know, say, a point on this line, say 1, and then 4 times 1 squared plus 1, so that's going to be 5. So could you go through and do it with this point here? A prime is 1, 5. And I think that you can. In fact, I'm certain that if you had this, you can. So what's the difference? The difference is that you just have a little bit more algebra to look after with the point A, yeah? But the process that you'd go through for this point here is identical to the process that you're going through with point A. So please don't worry too much. You know how to do this. Just make sure that you follow the same process. And if you're finding it difficult, try it with something simpler first. Try drawing a diagram. Try making it easier for yourself. Yep, so try using these thinking skills and these thinking routines to make your own life a little bit easier.